The trains are running for a very, very long time and hundreds, thousands of kilometers, and therefore we need a long-lasting solution. It must be absolutely safe, and it must be also a kind of an easy-to-use technique.
Welcome back to another episode of Better Made with Adhesives. Today we have a very specific topic, and it's actually based on your demands. So we want to talk today about glass installation in the rail market. And for that topic, I have with me today Ulli Mueller. He is one of our experts in Sika, and today we want to talk about glass bonding specifically in the rail industry. So welcome, Ulli.
Thanks to be here.
Glad to have you. Now, Ulli, when we talk about this topic of glass bonding, what do you think are the key requirements in this market?
I think it's the key requirements for bonding is, especially for the rail business, is the time. So we need long-lasting solutions because the rails or the trains are running for a very, very long time and hundreds, thousands of kilometers, and therefore we need a long-lasting solution. It must be absolutely safe, and it must be also a kind of an easy-to-use technique, which is quite important.
I absolutely agree. This is also what we hear from the market. Operators actually demand lifetime of trains from over 30 years. And actually, there's a rolling stock around in, not necessarily in Switzerland, but in other countries, which is over 60 years even. Now, Ulli, this leads me to my next question. You mentioned actually longevity. And this, I guess, is we know it's a challenge for everyone, not only for the bonding solution, but what are, in your opinion here, the key points to consider?
The key points to consider is, on the one side, the design of the joint as well. It must be proper designed that the joint can take over the loads, all the external and internal loads coming from wind and dynamics and so on. We need a good adhesion, of course, to a rubber substrate, so which stays as well for a very long time. And then the application, I think it's very important. The materials have to be applied correctly, and then they will also stay for a very long time. We have to avoid any kind of voids and gaps, because possible water ingress may lead to corrosion. Of course, nobody wants to have.
No, absolutely. And actually, we have been part also of couple of dismantling of front caps of trains, and there we have actually the proof, because we did all the tests required to understand how well was the adhesion, how well is still the mechanical performance of the product, and we got confirmation that the adhesive system can last easily 20 years and beyond. And we had some areas where we had adhesion loss, and this is exactly what you mentioned. It was because of the corrosion. So the corrosion went underneath the bond line, and that caused then, of course, a loss of adhesion. Yeah. Now, this leads me actually to the next point. You also mentioned the topic of gaskets. And what do you think are the biggest downsides of the gas?
The biggest downside of gaskets is that you are bringing or you are fixing the glass into a system where you have to work very, very accurately. And if you do it accurately and right, maybe it's also long-lasting. But as soon as minor mistakes happen, as soon as tolerances are in the game, then of course with the vibrations of the train. So we are not talking about this high-speed trains running very smooth, but we are also talking about the tramways, for example, and so on, where you have a lot of vibrations in. The glass can move a little bit here and there, and the risk of water penetration would be there then as well. And then with the water penetration, we are coming back to the topic of corrosion. For sure, nobody wants to have, because it leads to can lead to huge maintenance topics finally.
Absolutely, and it's exactly what you say. It's true. No? You have oscillation because it's not really a fixed system. Then you have capillary effects, so the water is almost sucked in. And actually we get also confirmation from some operators it's not a matter if they will have corrosion, it's just when. And it's clearly proven that bonded system lasts longer than gasket clay system because of these reasons actually. Now, there are different systems utilized in the rail market. We have, as we mentioned, we have fully bonded systems, we have gasket glazed system, we have mix with bonded frames and then gasketed windows into the frame, etc. What would you say are the downsides or the benefits of those different systems in general? Maybe?
It's maybe less a technical question in this regards, but the reasons are different. The reasons are the final use of the train. Some of the trains cannot be, or you cannot use gaskets, it's just not possible. Mm-hmm. Then you have the topic of production you have to consider. If you're producing trains, very similar trains for long term, then maybe cassette windows might be the easier and faster solution to bring in. If you're producing very special trains where a kind of build up as kind of supply chain or efficient supply chain is not as easy, you are bonding directly to the wagon. So therefore, the difference are really, or the reasons are very difficult or different, and therefore a clear reason to say this or the other solution is the best, from cassette window, bonding a cassette window, bonding directly into the wagon, cannot be given.
Yeah, okay. Yeah. I guess, yeah, you're right. But when we look now we have different kind of segments. We have light rail, we have commuter trains, we have high-speed trains. Could we actually here differentiate a little bit what systems are preferred or actually even must be used?
Yeah, you are absolutely right. There are already, I will say, two kind of trains, or train series, if you want to call it like this, where bonding is, let's call it, close to mandatory. You have all the high-speed trains that definitely you are bonding the glasses to the frame and sealing afterwards with a proper material. The reasons are vibration topic, acoustic topics, aerodynamic topics, cleaning topics, and therefore here definitely bonding is the best solution. And then we are talking about the trams or streetcars, where you have it as well, because here, as a lot of people know, the glasses are just much bigger.
Yeah.
So the tramway is consisting close to everything out of glass, and as bigger the glasses, as more difficult it is to frame them. Framing might be possible, but under all the other aspects, framing tight, avoiding corrosion again, and so on, bonding and sealing is the better solution.
Yeah. Yeah. One concern actually operators raise very often is, actually it's two concerns. One you mentioned is the time to maintain a vehicle, and if you have a lot of corrosion, this takes longer apparently. But another point is when we replace glasses, or they replace actually glasses, it's the standstill time. And how can we respond to that actually?
I think, Martin, here we have now very good solutions in place. We have designed for maintenance solution, meaning accelerated adhesives, which can reduce the standstill time close to a minimum. For the moment it's 4 hours. It's, as you know, the product Sika Flex 268, existing in a special application equipment called Power Cure gun, to really have a very flexible solution for on-site repair, which really brings the downtime to a minimum and helps the customer to bring not only the train back to traffic fast, but also safe, especially for the rail business. I think a very important point.
Yeah, and this is, I think it's also an important message to many operators out there which are still using older system, which demand longer standstill time. So why don't you switch also to 268 Power Cure, as many others did? And if you have a concern about isocyanates, we have our Pureform technology with the Sika Flex 668 and the Power Cure version here as well, which enables even a faster reduction of standstill time. So Ulli, this leads me actually to my last question. How do you see the future of bonded windows in the rail industry?
I see it very positive, because we have proven examples, as we already talked about, the high-speed trains up to the other side of the spectrum, the streetcars, they are already bonded. So there's a lot of proven examples existing. We have very good materials for designed for this application, which were maybe in the past not available on this kind of quality level. Plus, in combination with future requirements also of operators in regards of comfort of the trains or aesthetical topics, if we are talking about banded glasses and so on, bonding, in my opinion, is just the future. And then I think also one important point I want to mention here as well is also from the manufacturing point of view or the producer of trains. Here today we have much more educated people who really know what they are doing with the adhesive, trained in the different kind of sectors.
Like with DIN 6701.
Following all these requirements, as you mentioned. And then, so therefore I see it very, very positive, and I have not only the feeling, I'm sure about that bonding will be the future for fixation of glasses into trains.
Excellent closing statement, Ulli. Thank you very much for the discussion. Thank you to our viewers for watching. And by the way, if you have any other specific topic you want us to tackle, let us know. And with that, thank you very much for viewing, and once again, thank you to Ulli for this discussion.